Alright, so today we move into another topic. So it's going to be a topic in the section of geometry as we have it here. So today we're going to be covering the topic of circles. So it's circles under geometry. Alright, so let's learn about circles. Alright, so circles it is. So a circle is a locus of all points P, X, Y, which lie at equal distances from a fixed point. So that fixed point is what we call the center, and we're going to have the coordinates of the center being as A, B. A shall be representing the X value of the center, then B shall be representing the Y value of the center, which is the center of the locus. So this is how we can have it. So if we put this in a Y and X axis graph, I'll have it this way. So that's the center right there. So the center is AB, and then we can actually see that this locus or this circle has a radius. Then as you can see, that is the point PXY. And then we can construct it this way. So as you can see, we can label that point as point X, then you can label that as point Y. So we're going to be using all these forms to actually find the equation of the circle. So this is the locus of points, and R is the radius of the circle. So suppose the distance of point P from a given fixed point C is as shown above. R is then found from, as you can see, CP squared from Pythagoras theorem to that right angle triangle we have there. We can see that CP squared shall be equal to CN squared plus NP squared. And then when we substitute in, we can see that R shall be equal to CP, and then we can see that Cn shall be equal to X minus A, and then NP shall be Y minus B squared, of which we remember that CP is R, but remember that since we're squaring it, it shall become R squared. So therefore, this is the general rule of a circle. So this is how it is written. Alright, so now we're going to expand the general rule to form a Cartesian form of it. So this is the general rule expanded. As you can see, when we expanded X minus A, we got X minus A squared, we got X squared minus 2AX plus A squared. And then when we expanded Y minus B squared, we got Y squared minus 2BY plus B squared is equal to R squared. And then next we can actually collect terms that actually look alike. So as you can see, we have X squared plus Y squared, so let's bring this together, minus 2AX minus 2BY plus A squared plus B squared is equal to R squared. Then next I can bring the R squared into this side and then leave a 0 on the other side. Alright, so what is usually done is we're going to let A squared plus B squared minus R squared to be equal to C. So we're going to be representing these three using a letter C. So we'll have X squared plus Y squared minus 2AX minus 2BY plus C being equal to 0. Then next we're going to make the coefficients of X and Y positive, because now I don't want to have those negatives in the general equation. So we shall let small a be equal to negative G, and we shall let small b be equal to negative F. The equation then becomes X squared plus Y squared plus 2GX plus 2FY plus C being equal to 0. So now this is another form of expressing the equation of a circle, and we call this form the Cartesian equation of a circle. So either way, in both of the two ways we've actually shown, we can represent an equation of a circle depending on what we're being asked for. So we'll be using both of them interchangeably in all the different questions, but this is how we prove them. Alright, so to find the center and radius of the circle, we've just stated that A squared plus B squared minus R squared is equal to C. So we can see that if we make R squared the subject, R squared shall be equal to A squared plus B squared minus C. And then R shall be equal to root of A squared plus B squared minus C. So then that is going to be the equation that we can use to find the radius. Then the center of the circle, AB, so this is the way we can represent it. So A represents the X coordinate of the center, and then B represents the Y coordinate of the center. Then we can see that we can actually represent A with negative G, and we can also represent B with negative F. So as usual, we shall also be using this interchangeably. Whether we have it in the forms of G or in the forms of A and B, it won't matter. So we shall just be using them interchangeably. Alright, let's look at question number 1. So we're being told to show that the point 2, 5 lies on the circle x squared plus y squared minus 2x minus 6y plus 5 is equal to 0. So how do we prove that a point lies on the circle? So this is the equation of the circle that we actually have. So the way we prove it is by substituting these values here. So for the x coordinate we shall substitute it with 2, and for the y we shall substitute it with 5, and then we shall have to prove that the values, when we plug these values into the equation of the circle, we actually get a 0. If that is true, then that point lies on the circle, and if it's not true, then the point does not lie on the circle. So at the point 2, 5, this is what we'll have. Simplify this further and I'll have everything giving me 0. So 0 is equal to 0. So therefore, the point 25 lies on the circle. So that's how we prove that a point lies on a circle. Question 2. Find the equation of the circle whose center lies at the point 3, 4 and has a radius of 5 units. Alright, so let's see this. Alright, so first of all I'm going to sketch the circle. So that is the center of the circle. And then we've seen that the radius is 5 units. And then that point xy is the point on the circle. And then we shall see that the center is 3, 4. So we're being told to find the equation of the circle. We've been given the center, we've been given the radius. So how do we find the equation of the circle? So now we shall have to remember that from general equation of a circle, x minus a squared plus y minus b squared is equal to r squared. So we're going to be making use of this. So good enough, we know the value of the radius, which is 5, and we know the values of a and b. So a shall be equal to 3 and b shall be equal to 4. So now that we know this, we can actually find the equation of the circle. So you just have to substitute those in. So I have x minus 3 squared plus y minus 4 squared is equal to 5 squared. So when I expand this, I have x squared minus 6x plus 9 plus y squared minus 8y plus 16 being equal to 25. So now, next I can see that I can bring this 25 to this side, of which I can say 9 plus 16 is 25. And then when I bring this 25 to this side, I have 25 minus 25, which is 0. So lastly, this is what I'll have. So I can bring this closer to the x squared. So I have x squared plus y squared minus 6x minus 8y is equal to 0. So this is the equation of the circle with this center and with that radius. Question 3. Find the equation of the circle whose center is at the point 2, 1 and which passes through the point 4, negative 3. So let's sketch this also. So as you can see, the center is given as 2, 1. Then we've been told that it passes through the point 4, negative 3. So the difference here is we've not been given the radius. But how do we solve this? Again, we can use the general equation of a circle to actually do something. So now we can see that the general equation of the circle is given this way. As you can see, first of all, the first step shall be to find the value of the radius. How are we going to do that? So as you can see, we can actually plug in the value of x as 4 and the value of y as negative 3. Then we can use this center here, so where a shall be 2 and b shall be 1, and we shall use this to find the value of the radius. So when I solve this, I'll have 2 squared plus negative 4 squared, which is the same as 4 plus 16 is equal to r squared. So this shall be r squared is equal to 20. Then r shall be equal to root of 20. So now that I know the value of the radius, I can again substitute for r into the general equation of a circle again, and now solve and find the equation of a circle. So we're going to be using this general equation again, but this time we'll leave x and y as they are, but we're going to substitute in the value of the center and the value of the radius to find the equation of the circle. So from the same equation, the general equation of a circle, I'm going to plug in the values we found. So r is root of 20, so I have root of 20 squared, and then remember that a is 2 and then b is 1. So when I expand this, I'll have, this will give me x squared minus 4x plus 4, then this will give me y squared minus 2y plus 1, and then root of 20 squared is 20. So now I can actually bring this 20 in, and then I'll have it as you can see, 4 plus 1 is 5, so I'll have 5 minus this 20, everything being equal to 0, and then it will be x squared plus y squared minus 4x minus 2y minus 15 is equal to 0, and that is the equation of the circle. Question 4. Find the area of a circle. X squared plus y squared plus 10x minus 4y plus 21 is equal to 0. Alright, so this is the equation of the circle that we've been given. So now, first of all, before I find the area of a circle, I need to know the radius of that circle, and then it will be through finding the radius and the center that I can actually find the area of the circle. So first of all, we've been given the equation of a circle already in Cartesian form. So what I'm going to do is I'm going to extract out the center values and then the radius from this equation. So I'm going to compare with the general Cartesian equation of a circle. So remember, the general Cartesian equation of a circle is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So when I compare the two, I can actually see that where I have this 2gx shall be equal to 10x. But we said the x values cancel, so that means I shall just say 2g is equal to 10. And then if I make g the subject, g shall be equal to 5. I can also see that 2f, which is the value right here, shall be equal to negative 4. And then if I make f the subject, f shall be equal to negative 2. Then I can also see that c is represented as 21, positive 21. So now I can see that therefore I can now find the radius of the circle. So now the radius shall be equal to root of g squared plus f squared minus c. So plug those in and I'll have it as, so I can have the radius as root of 8 units. So now knowing the radius, I can now easily find the area of the circle. Now the area of the circle, remember, is pi r squared. So plug those in and I have pi times root of 8 squared, which is the same as 8 pi. So the area of this circle is 8 pi units squared, and that is the answer. Question 5. A point A4 lies on a circle whose equation is bracket x plus 3 squared plus bracket y minus 6 squared is equal to 36. So part A, find the coordinates of the center of the circle. Part B, the radius of the circle, and C, the values of A. Alright, so let's solve this. So this is what we're going to do. So we're going to compare this. Now we've been given this equation here in the general form. So this is the general form of the equation of a circle. So if we compare it with this form of the general equation of a circle, we can easily see that what we'll have is this. So you can actually see that this negative a is equal to 3, of which a shall be equal to negative 3. Then you can also see that b is actually equal to 6. Therefore, the center of the circle is negative 3, 6, and that's what we have as the center of the circle. Then part B, the radius of the circle. Now you can actually compare this and you can see that r squared is equal to 36. Of course, this will mean that if we find the square root of both sides, r shall be equal to 6 units. Now for part C, we need to find the values of A. Now we've been told that this point lies on the circle, so that means that we can actually plot it this way. So this is what we have. So the radius is 6 units, the center is negative 3, 6, and then that is the point that lies on the circle. Alright, so we're going to make use of the general equation of a circle. Now what we're going to do is, since that point lies on a circle, it means we can plug in its points for the x and y. But we already know the values of a and b are already given, and we know the value of the radius. So as we can see, small a here shall be equal to 3, and then b shall be equal to 6. Now we're going to plug in the points that were lying on the circle. So the points were a, 4. So where there is x, we're going to put in small a, and where there is y, we're going to put in positive 4, and radius is 6. So we have 6 squared. So now when I solve this, this is what I'll have. So 4 minus 6 is negative 2 squared. And then when I expand this, I'll have a squared plus 6a plus 9, plus this will give me 4 being equal to 36. Now 9 plus 4 is 13, then 13 minus this 36 will give me negative 23. So I have a squared plus 6a minus 23 is equal to 0. So this is a quadratic equation. Alright, so when I solve this quadratically, I'll have a as either being equal to 2.657 or a being equal to negative 8.657, and those are the answers. Question 6. Find the radius and coordinates of the center of the circle. 2x squared plus 2y squared minus 8x plus 5y plus 10 is equal to 0. So now I can easily compare this with the Cartesian equation of a circle to find the radius and the coordinates of the circle. But as I can see, I have 2 here and I have a 2 here. So what happens is, for me to compare with the Cartesian equation of a circle, I need to eliminate these values, these coefficients in front of the x squared and y squared. And how shall I do that? I shall divide everything by 2, and that shall work. So now this is the Cartesian equation of a circle to be comparing to, But first of all, we're going to divide all sides by 2. So when I divide everything by 2, I'll have x squared plus y squared minus 8 over 2x plus 5 over 2y plus 10 over 2b equal to 0. So this will give me x squared plus y squared minus 4x plus 5 over 2y plus 5 is equal to 0. So now that I have this, I can now compare with this Cartesian equation of a circle. So first of all, I can see that this 2gx or this 2g shall be equal to negative 4, of which g shall be equal to negative 2. I can also see that 2f shall be equal to 5 over 2, of which f shall be equal to 5 over 4. Then I'll have c being equal to 5. So now I can see that since I have the values of g and f, I can actually now state the coordinates of the center. So remember, the center of the circle shall be negative g, comma negative f, which is what we represent as a and b. So we shall say the values shall be, so negative g shall be 2, and then negative f shall be equal to negative 5 over 4. And these are the coordinates of the center of the circle. So next I can find the radius from this formula. So plug in the values and I'll have root of 9 over 16, which shall give me 3 over 4 units. And those are the answers. Question 7. So being told that the equation of a circle with center O is given by x squared plus y squared plus capital AX plus capital BY plus capital C is equal to 0, where A, B and C are constants. Given that 4A is equal to 3B, 3a is equal to 2c and c is equal to 9, find the coordinates of the center of the circle, and then part B, find the radius of the circle. So this is an easy one. So now part A, we can actually first of all see that we've been told that 3a is equal to 2c. Now we've also not been told that c is equal to 9. So we're going to plug the value of 9 here. So that means 3a shall be equal to 2 times 9, of which 3a shall be equal to 18 and a shall be equal to 6. So now we know that the value of a is 6. We can now find the value of b from this group here. So now we can see that 4a is equal to 3b. Plug in the value of a and I'll have 3b being equal to 24, of which b shall be equal to 8. So now I know the values of a, b and c. So therefore the equation of the circle becomes x squared plus y squared plus 6x plus 8y plus 9 is equal to 0. So now that I know this, I can easily find the coordinates of the center of the circle. So I'm going to compare with the Cartesian equation of a circle, and then when I compare, I can see that 2g shall be equal to 6, of which g shall be equal to 3, and then 2f is equal to 8, of which f shall be equal to 4. And then we can see that the value of c is basically 9. Now I can find the center of the circle. So now when I plug it in, I will have it as negative 3, negative 4. And those shall be the coordinates of the center of the circle. Now for part B, I need to find the radius of the circle. So I'm going to use the formula. So plug in the values and I'll have it as root of 16, of which I'll have it as 4 units. So that is the value of the radius of the circle, and that is how we work this question. So question 8 is a question from UNEB 1997, and this was question 5. So I'm being told that ABCD is a square inscribed in a circle, x squared plus y squared minus 4x minus 3y is equal to 36. Find the length of diagonals and the area of the square. So we're not drawn for the square, so that means we have to sketch it ourselves. So now I'm going to first draw a circle. Then as we've been told in the question, we've been told that the square is inscribed inside the circle. So now we're going to place the square inside the circle. And then we shall label one of the points A, another point B, another point C, and another point D. So now next, I can actually see that that is going to be the center of the circle. And then as we can see, I can now compare the diameter of the circle to the values that the square shall give me. So that is the center of the circle. And then we can actually see that the dimensions of the square, since all sides of a square are equal, I'll have them as x and x. And then r shall be representing the radius, and then the other r shall be representing the other part of the radius. So that's the diagram that we have. Then you can actually see that since this part here is a right angle, it means that this angle here is 45 degrees. Alright, so first of all, this is the equation of the circle that we have. So first of all, I can find the coordinates of the center, and then I can also probably find the values of the radius. So when I compare this with the Cartesian equation of a circle, I can see that 2g shall be equal to negative 4, of which g shall be equal to negative 2. and then 2f is equal to negative 3, of which f shall be equal to negative 3 over 2. So now I can state that the center of the circle is c is equal to 2, comma 3 over 2. Alright, so now that I know that, I can also find the radius of the circle. Alright, so the radius shall be equal to that. As you can see, the value of c that was given in the question was a negative 36. So when you plug this in here, because this is a minus, it shall become a plus. So now I'll have it this way. So solve this further and I have root of 169 over 4, which shall give me 13 over 2 for the radius. And this is the same as 6.5 units. Alright, so next I can calculate the length of the diagonals. Alright, so now that I know that, I need to find the length of the diagonals. As I can see, the diagonals shall be equal to this value of db. Of course, this value of db is the same as the value of AC. So that's the diagonals that we look at. So now if I find the value of db, I shall actually have found the values of all the diagonals. So we can say that db is equal to 2r. So length of diagonals from db is equal to 2r shall be 2 times 6.5, which shall give me 13 units. So that is the length of the diagonals. Now to find the length of the sides, we've seen that the length of the sides are equal to x. So what I'm going to do is I'm going to extract out this part of the square. I'm going to extract out a, b, d. So to find the length of the sides, when I extract out a, b, d, this is what I'll have. So I'll have a right angled triangle. So I'll have a right angled triangle, of which I know the value of db is 13. So now I can solve this using SOHCAHTOA. So I've chosen to use sine. So we can say that sine of 45 shall be equal to opposite over hypotenuse, which is x over 13. So I'm looking for the value of x. So we can say that if I make x a subject, x shall be equal to 13 sine 45. But remember that sine 45 is the same as root 2 over 2. So I have 13 root 2 over 2 units as the value of x. Alright, so next we are told to find the area of the square. But remember, the area of a square is side times side. So I'll have the sides as x times x, which is this times itself. And then the answer I'll get is 338 over 4, which shall give me 84.5 square units. And that is the answer. Alright, so next we look at obtaining equation of a circle given 2 points and a line on which its center lies. So now, this is a unique question. So I've been told to find the equation of the circle passing through the points 2, 3, and 4, 5, having its center on the line y is equal to 4x minus 3. So the reason this is unique is because we've already been told that the center is lying on a certain line y is equal to 4x minus 3, and the circle is passing through 2 points. So let's first sketch this to demonstrate what we are being told in the question. So as you can see, that is the center AB. Then we have 2 points. We're going to call them point A and B, of which I can see that point A is 2, 3, and then point B is 4, 5. As you can see, the distance from the center to each one of these points shall be equal to radius. So that's why we have these lines there. Then as we've been told that the center lies on the line y is equal to 4x minus 3. So that is the line passing through the center. Alright, so since the center CAB lies on the line y is equal to 4x minus 3, it simply means we can actually substitute in the coordinates of A and B into this equation. So we can actually see, so remember that B represents the y coordinate of the center and A represents the x coordinate of the center. So you can actually plug in A and B into this equation. So as you can see, where there is y, I'll actually place in the B, and where there is x, I actually place in the A. So now I'll have it as B is equal to 4A minus 3. So this shall be the new format. So now, so the coordinates of the center are now equal to this. So we've seen we represented B as 4A minus 3. So now the coordinates of the center, now let's put B. So where there is B, we're actually going to put 4A minus 3. So we have the coordinates of the center now being A, 4A minus 3. Now, since the points A, 2, 3 and B, 4, 5 are equidistant from the center, that means they're the same distance from the center. It simply means that the distance AC is equal to the distance BC. Now, to find the distance AC, we find the distance AC from the formula 2 minus A squared plus 3 minus B squared in a root being equal to, now to find BC, BC shall be 4 minus A squared plus 5 minus B squared, and that shall also be in a root. So next I can say the next step is to eliminate the roots by squaring both sides. So when I square both sides, this is what I'll have. So next I'm going to expand each one of these, but before I do that, I shall remember that b was actually represented as 4a minus 3 on both sides. So when I open the brackets, I'll have it as 3 minus 4a plus 3 on both sides, and here will be 5 minus 4a plus 3. Alright, so next this is what I'll have. So simplifying this shall be 3 plus 3, which is 6, and then this shall be 5 plus 3, which is 8. So next I can open the brackets, and this is what I'll have. So first thing first, I can actually see that some values will add. 36 plus 4 will give me 40. Then I can see that negative 4a minus 48a will give me negative 52a. Then a squared plus 16a squared shall give me 17a squared, being equal to, so on this other side, 64 plus 16 will give me 80. And then negative 8a minus 64a will give me negative 72a, plus I can set a squared plus 16a squared shall give me 17a squared. So next I can see that this and this will cancel, and I'll be left with 40 minus 52a being equal to 80 minus 72a. So collecting like terms, I can actually see that if I bring this 40 to this side, 80 minus 40 will give me 40. Then take this 72 to this side, and I'll have it as 72 minus 52a, which will give me 20a. Now if I make a the subject, a shall be equal to 40 over 20, of which a shall be equal to 2. Alright, so now that we know the value of a, we can find the value of b. So remember that b is 4a minus 3, so plug in that, and I'll have b being equal to 5. So now that I know that, I can now therefore see that the coordinates of the center are, since we know the value of a and b, the coordinates of the center are 2, 5. Alright, so next we can calculate the radius. So now we're going to calculate the radius. So we're going to make use of the points, any points that you choose. So I've chosen to use the points 2, 3 that were already given in the question. So now I'm going to use this formula right here. Since I know that the center is 2, 5, so a is 2 and 5 is b, I can now, using the points 2, 3, so what happens is for the x I'm going to use a 2, and for the y I'm going to use a 3. Now it doesn't matter which point you use. Even if you use the other point with 4, 5, you would still get the same answer. So now plug in this, and I'll have 2 minus 2, which is 0, and then this will give me 3 minus 5 squared, which is negative 2 squared, being equal to r squared. Now I shall get the radius as being equal to 2 units. So the radius is 2 units. So now that I know the value of the radius, I can now find the general equation of a circle. So I shall use this general equation to actually solve it. So now I know the center coordinates, and I know the value of the radius. So when I plug those in, I'll have it as x squared minus 4x plus 4 plus y squared minus 10y plus 25 is equal to 4. So simplify this further. 25 plus 4 is 29. Now next I'm going to bring this 4 here, and 29 minus 5 will be 25. So the equation of the circle shall be x squared plus y squared minus 4x minus 10y plus 25 is equal to 0. So therefore that is the equation of the circle, and that is what they wanted. So question 2. Find the equation of the circle passing through the points 2, 3 and negative 1, 1, having its center on the line x minus 3y minus 11 is equal to 0. So this is quite a similar question to the one that we've done before. So we're going to sketch this. So this is what we have. So we have that line passing through the center, and then the center is CAB, and then we have 2 points on the circle that are given. So next we're also going to say that since the center CAB lies on the line x minus 3y minus 11, it means we can substitute the values of x and y with a and b. So where there is x we shall put in a, and where there is b we shall put in, where there is y we shall put in b. So I have a minus 3b minus 11 is equal to 0. So if I choose to make a the subject, a shall be equal to 3b plus 11. So now that I have the value of a in terms of b, I can see that therefore the coordinates of the center are now, so this is what I have. So where there is a, I'll put 3b plus 11 comma b. So now since the points a, 2, 3 and b negative 1, 1 are equidistant from the center, which means they're the same distance from the center, it means that the distance SC is equal to the distance BC. So now this is the formula for the distance of SC, and that's the formula for the distance of BC. So next I square both sides, and this is what I'll have. So next where there is a, I'm going to substitute in with 3b plus 11 on both sides. So open those brackets, and that's what I'll have. So simplify this further. I can say 2 minus 11 will give me negative 9, and here negative 1 minus 11 will give me negative 12. So when I open brackets, this is what I'll have when I expand them. Then simplify this further, and I'll have it being equal to that. So next I can see that this 10b squared and this 10b squared cancel, and I'll be left with 90 plus 48b being equal to 145 plus 70b. So solve this further, collect like terms, and I'll have negative 22b being equal to 55. So b shall be equal to negative 55 over 22, of which b is equal to negative 5 over 2. So now that I know the value of b, I can solve for a. A shall be equal to 3b plus 11, which is what we had said. Substitute in for b, and I'll have a as being equal to 7 over 2. So now that I have these are the coordinates of the center, I can actually see that we can calculate the radius. So use any of the points that you choose. So I've chosen to use the points negative 1, 1, but you could use any points. Even the points 2, 3 would also work and give you the same answer. So now plug those in. So that means where there is x, we shall put in negative 1, and where there is y, we shall put in 1. And this shall be the values of a and b. So as I can see that because this is a minus and b is negative 5 over 2, I'll have it that way. So that negative will give me a plus, and then 1 plus 5 over 2 will give me 7 over 2. Then here negative 1 minus 7 over 2 will give me negative 9 over 2. So when I square those, I'll have 81 over 4 plus 49 over 4 is equal to r squared. So when I add those, I'll have 130 over 4 is equal to r squared, of which r shall be equal to root of 130 over 4. So now that is the value of the radius. So simplify this further, and it would be root 130 over 2 units. Alright, so from the general equation of a circle, I can actually now find the equation of the circle. So plug in all the values that we had yet found, and then this is what I'll have. So when I square these values here, I'll have 130 over 4. Then here I can actually say that this will be left as y plus 5 over 2. So when I expand these, open the brackets, I'll have x squared minus 7x plus 49 over 4, plus this will give me y squared minus 5y plus 25 over 4 is equal to 130 over 4. Alright, so next I'm going to collect terms that are like together. So this is what I'll have. So now this added together minus 130 over 4 will give me 56 over 4, which is the same as 14. So I have it as x squared plus y squared minus 7x minus 5y minus 14 is equal to 0, and that is the equation of the circle. So that is the equation that we've found, and that's the answer that they wanted. Alright, so next to move on, so next we're going to be looking at equation of a circle touching x-axis, y-axis, or both. So let's look at this question 1. So being told to find the equation of a circle with center 2, negative 3, which touches the x-axis. So what happens here is I just simply have to sketch. So this sketch is just going to be just according to the interpretation. So I just have to sketch a circle which touches the x-axis. But make note of this, that the center of the circle is the x value shall be a 2, and then the y value should actually be a negative 3. So what does this mean? So if the y value is a negative 3 and the x value is a positive 2, what that simply tells me is the circle is in the 4th quadrant. So now that means our sketch will look something like this. So the circle is actually in the 4th quadrant, where y can be a negative and x can be a positive. And we'll be told that the circle touches the x-axis, so we've actually made it touch the x-axis. So that is the center right there. So now we are sketching the radius, and then I can see that that coordinate of the x shall be 2, and then the coordinate of the y shall be equal to negative 3. So this is the sketch that we have. So now there is something we can actually already see right here. So do you notice that the value of radius here is actually equal to 3 units, as you can already see? So that is something you notice when you actually make a circle to touch the x-axis. So you can see that the radius r is equal to the y coordinate. So r is 3 units. So now that is going to be the interpretation. So this is how we look at it. So when a circle touches the x-axis, the radius is equal to the y coordinate. So from the general equation of a circle, we can now solve this since we already know the center values. So you can actually plug in the values of r and the values of a and b, and we'll have it as x squared minus 4x plus 4 plus y squared plus 6y plus 9 is equal to 9. So when I simplify this further, I'll have it as x squared plus y squared minus 4x plus 6y plus 4 is equal to 0. And this is how we find the equation of the circle when it touches the x-axis. Alright, so another question. Find the equation of a circle whose y-coordinate of the center is -7. So pay attention that the y-coordinate of the center is -7. The radius is 3 units and also touches the y-axis. So this is a circle that touches the y-axis. Alright, so let's sketch it. So now we've seen that the y-coordinate of the center is -7. So that basically means that the circle shall be in the 4th quadrant. So basically this is the best way I can imagine it to be. So the circle is touching the y-axis. So you can see that this is its center value shall be a comma -7. So we don't know the value of a in this case. So we're just going to leave it as a. We don't know the x coordinate of the center. So it's a comma and the y coordinate of the center is -7. So the radius, we remember, is equal to 3 units. So now this value here, so the y coordinate of the center, this value here shall actually also be equal to -7 at this point. And then since the radius of the circle is 3 units, it means that the distance from here to the center is 3 units. That simply means that this coordinate here is also equal to 3 units. So that basically means that with the radius r is equal to the x coordinate, a is equal to 3. So we can already see we can actually easily find the x coordinate of the center. So it's going to be equal to 3. So now that I know that and I know the radius, so I can use the general equation of the circle to find the equation of this circle. So plug in the values and I'll have it as x squared minus 6x plus 9 plus y squared plus 14y plus 49 is equal to 9. And the equation of the circle shall be x squared plus y squared minus 6x plus 14y plus 49 is equal to 0. Oh, so here is another one. Find the equation of a circle whose center is on the x-axis at -5 and radius is 9 units. That means the center is on the x-axis as -5. So let's plug it this way. So where is the negative part of the x-axis? That actually means that we shall be in this negative region. So basically we can actually see that the center shall be on the coordinate where we have -5. So since the center is on the x-axis, it basically means that the y-coordinate of the center shall be equal to 0. So this is what we'll have right there. Now since the radius is equal to 9 units, it means that the distance from here to here is 9. So that means that this shall be 9 on the y-axis. It also means that the distance from here to here is 9. So this shall also be the -9y on the y-axis. So what can we observe? We can see that when the center is on the x-axis, b is equal to 0. So the y-coordinate of the center is equal to 0. So that means from the general equation of a circle, we can actually put in a 0 where we have a b. So this shall now give me x plus 5 squared plus y squared is equal to 81, of which I'll have the equation of a circle being equal to x squared plus y squared plus 10x minus 56 is equal to 0. And that is the answer. Question 4. Find the equation of a circle whose center is on the x-axis at 2 and radius is 3 units. That means that we're in the positive region of the x-axis. So now the center is also on the x-axis, so we have it as at 2. But now we can actually see that since that center is on the x-axis, it also means that the y-coordinate at that point is 0. So since the radius is 3 units, it means that we shall have 3 up there and we shall have 3 at the bottom. Now when center is on the x-axis, we can also again see that b is equal to 0. So that means that now we know the value of b. So now we can solve and find the general equation of the circle from this formula. So you shall have x minus 2 squared plus y squared is equal to 9, of which I shall have it as x squared plus y squared minus 4x minus 5 shall be equal to 0, and that is the equation of the circle. Question 5. Find the equation of the circle whose center is on the y-axis at -3 and the radius is 6 units. So now where is the y-axis a negative? It means that we are going to be in the negative region of the y-axis. That is right here. So the center is on the y-axis where it's -3. So now I can also see that the x coordinate of the center shall be equal to 0 at that point. Now the radius we've been told is equal to 6. So that means that up here we shall have this as -6, and we shall also have this part here as +6. So now we can see that when the center is on the y-axis, a is 0. So that means that now we know the value of a. So you can use the general equation of a circle to find the equation of this circle. So plug in the values and I'll have it as x squared plus y squared plus 6y plus 9 is equal to 36, which it will eventually give me x squared plus y squared plus 6y minus 27 is equal to 0, and that is the answer. Question 5. Find the equation of a circle which passes through the origin and whose center is on the y-axis at 0, -6. So now that means we just have to first locate the point on the y-axis where we have 0 and -6. That means that the y-coordinate of the center is a negative. So that means that we're in the region where we have a negative, and the x-coordinate is 0. So we shall have the center on the y-axis. And then we've been told that it also passes through the origin. So that's why we have it passing through the origin where we have 0, 0. So this is what we'll have right now. So now when I plug in the values, this is what I'll have. So now in this case, I can actually see that I also have -6 there, and then I'll have a 6 right there. And why is that? It's because already I can see that this value here from here to here is -6. So that basically means that the value of the radius is also equal to 6 units, because this distance is equal to this distance. So eventually it means that this coordinate here is 6, and then this coordinate here is -6. So when the circle passes through the origin and center is on the y-axis, a is 0 and r is 6 units. So from the general equation of a circle, this is what I'll have, of which this when expanded will give me x squared plus y squared plus 12y plus 36 is equal to 36, which will give me x squared plus y squared plus 12y is equal to 0, and that is the equation of the circle. Question 7. Find the equation of a circle whose radius is 4 units and touches both x-axis and y-axis, and whose center lies in the first quadrant. Alright, so that means that we've been told the quadrant where the circle lies in. So that means it's eventually in the first quadrant. So now this is where it lies, and we've been told that it touches both the x and y-axis. So that's how we have it that way, and we've been told that the radius is 4 units. Now as I can already see, it is already very clear that this distance from here to here, which shall be equal to the distance of the radius, is also equal to the distance of the x-coordinate of the center. Then this distance from here to here, which is also equal to the radius, shall also be the y-coordinate of the center, which is b. So in this case, when a circle touches both x and y-axis, we can see that since the circle touches both, the center is actually now going to be equal to 4. So you can actually see that the value of a is equal to radius, and also the value of b is equal to radius. So from the general equation of a circle, this is what I'll have. X minus 4 squared plus y minus 4 squared is equal to 4 squared. So this is what I'll have. So when I simplify this, it will give me x squared plus y squared minus 8x minus 8y plus 16 is equal to 0, and that shall be the equation of the circle. Question 8. Find the equation of the circle whose center lies on the line x minus 2y plus 2 is equal to 0, which touches both the positive axes. It touches the positive axis. So the difference in these questions, you've been given a line. So whenever you're given a line, it is good to first find the intercepts. So now let's first find the intercepts in this case. So now this is the equation of the line given. So we're going to look at the case when y is 0, x shall be equal to -2. And then when x is 0, we can say that y shall be equal to 1. So therefore the intercepts are p, -2, 0, and p, 0, 1. Alright, so we're going to first plot the circle. So now we've been told that it touches the positive axis. So when we say a circle touches the positive axis, it's the same as saying it is in the first quadrant, and since it touches both the positive axis, it also means that it touches both the x and the y axis. So that means we have it right there. So now next, that is the center of the circle. Alright, so now that we've placed the circle in where they have the positive axis, I can now see that the value of radius, the y value of the radius shall be equal to a and b because it touches both the positive axes. Now next I can now plot the line, and I can actually see that the line passes through the intercepts where we have 0, 1 and where we also have negative 2, 0, as you can see right there, and it also has to pass through the center. So that's how we draw the line x minus 2y plus 2. Now to solve this, to find the equation of the circle, now since the center CAB lies on the line x minus 2y plus 2, it simply means that we can actually substitute the values of a and b for x and y right here. So this equation shall become a minus 2b plus 2 is equal to 0. So when I make a the subject, a shall be equal to b minus 2. So now since the circle touches both the x and y axes, it means that the value of a shall be equal to the value of b, of which these two shall also be equal to the value of the radius. So now let's solve this. That means that now we have this, so where there is a, we can actually place in a b. So we have 2b minus 2 being equal to 2b minus 2 being equal to b, of which b shall be equal to 2. Now since b is 2, it also means that a shall also be equal to 2. So now the coordinates of the center are now c, 2, 2. And it also means that the radius is also equal to 2 units. So now I know that I can use the general form of the equation of the circle to find the equation of the circle. So expand this and I'll have x squared plus y squared minus 4x minus 4y plus 8 is equal to 4, of which the equation of the circle shall become x squared plus y squared minus 4x minus 4y plus 4 is equal to 0. So therefore that is the equation of the circle that they wanted. Alright, so as we come to the end of this first video of the introduction of circles, these are numbers I encourage you to try out and get better at your knowledge at everything that we've just discussed in this first video. So try this out and compare your answers to the answers that I actually have here in brown color to make sure you're actually on the right track. Alright, so the questions continue. Question 4, question 5, question 6, question 7, question 8, and then lastly I have question 9. So try these out and get better at your knowledge of this section. Thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. If it did, feel free to share the video with all your friends and help as many as you can. And then if you really like the video, feel free to give the video a like or a thumbs up, and then tell me in the comments if the video really helped you, and I'll try to get time and reply to your comments. And then if you're new to this channel, I encourage you to join the community by subscribing, and then make sure to hit the notification bell so that you get updated every single time I upload a new video. Thank you so much for watching, and I'll see you in my next video.